Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. The subject, Probability and Statistics, on which we are going to prepare this video lecture. The topic is Test of Significance for Difference of Means. What are the main topics we are going to discuss in this video lecture? A definition of population and sample, and difference of means. So the test statistic of two means, if two sample means occur, what is the test statistic? To find the test statistic in which the standard deviation of population is given and standard deviation of population which is not given, then what is the next alternative if it is not given? Everything in detail we are going to discuss. So the definition of population. The population, it's nothing but a large collection of individuals or numerical data is called a population. This population may be finite or infinite. If it contains finite number of individuals or members, then we will call it as finite population. If the members are infinite, it is not possible to count, then we will call it as infinite population. The samples are coming from the population. Suppose if you are taking a particular section, some 60 students are there. Then to analyze the 60 students, the total 60 students are population, then what is their academic performance? Some data which is defined, whether the defined data is correct or not, to analyze the same section, that is same population, any 3 students mark we can check it. So the 3 students are sample of that particular section. So a part of small section selected from a population called a sample. Now that samples, how many samples we have to take? That is sample which is denoted by the small n. If the data, the number in counting, if it is more than 30 or more than 30, then it comes under large sample. If it is less, then it comes under small sample. So the population, about what is a defined statement about the population, whether it is correct or not, to check the samples we are taking. That the relationship between population and samples which are drawn from the population is called sampling theory. So in Telangana, the number of engineering colleges, so all the engineering colleges academic performance, some data which is defined. So that is population. Whether the data then analyzed what is correct or not, to check, we are taking Institute of Aeronautical Engineering. So IARE, Institute of Aeronautical Engineering, is the sample for the population of the total engineering colleges in Telangana. So this is the tabulated value, that is critical values of Z. Here we have to take the decision, whatever the defined a statement about the population, whether it is correct or not, to analyze. This is the tabulated values. They are called as critical values of Z. Whether it is two-tailed test, what are the values? That is, if it is 1%, 5%, and 10%. Two-tailed test, this is the data. That is mod Z alpha, which is nothing but minus 2.5 to 2.58. This is from minus 1.96 to 1.96. Similarly, if it is a right-tailed test, the data which are placed under 1%, that is 0.01, 5%, 0.05, and 10%, 0.1. So now we will concentrate the test of significance for difference of means, under which we are going to do the problems. The research investigator is interested in studying whether there is a significant difference in the salaries of MBA grades in two metropolitan cities. A random sample of size 100 from Mumbai yields an average income of rupees 20,150. That is MBA. Two cities are there. One city, the name which is given, Mumbai. So the working people, they are getting the salary. So the average, the income, that is from working categories, from Mumbai actually working, that 100 persons we selected as sample. Their average income is 20,150. This is one part of the problem. Another random sample of 60 from Chennai. So from Chennai, we selected 60 persons. Their average income is 20,250. Two cities are there, that is two metropolitan cities, they are Mumbai and Chennai. From Mumbai, we selected 100. Their average income is 20,150, whereas Chennai, 60 persons we selected, their average income is 20,250. What they are asking? They are asking, is there any significant difference in the salaries of MBA grades? That is the working persons, the qualification is MBA grades. That we have to check. If the variance of both the populations are given as sigma 1 square 40,000, sigma 2 square 32,000 respectively. The question first we have to understand. So this is one category, that is Mumbai. From Mumbai, sample 100, sample mean 20,150. From Chennai, sample size, that is N260, sample mean X2 bar 20,250. Sigma 1 square, that is population, or given as variance of population is sigma 1 square, that is related to Mumbai, from where it comes, that population. Sigma 2 square, that is Chennai, that is regarding that 32,000. Is there any difference in salaries of MBA grades? That we have to check. What are the data are given? First we can write it. That is N1, just now we have discussed it, sample size equal to 100. Then X1 bar, that is the Mumbai, the sample mean is 20,150. Sigma 1 square, first population variance is 40,000. N2, that is Chennai, sample size is 60. X2 bar, then second sample mean is 20,250. Sigma 2 square, second population variance, that is 32,000. Yes, here the first point. The question they asked us to check whether there is any significant difference in the salary of MBA grades. First, we are telling null hypothesis, mu1 equal to mu2. That is, there is no difference. That is the average salary of between the two states, that is Chennai and Mumbai. So, mu1 equal to mu2. Null hypothesis, the symbol is H0. The second point is alternative hypothesis. We have to reject. Mathematically, what is the statement which is given to reject? Three ways are there: less than, greater than, not equal. But in the question what we are solving now, they told just is there any significant difference is there or not. If the question if it is increase more than, then we will go for right tail. If it is less than between the datas, Then we will go under left tail, that is if less than symbol is dominating. So here in this, what is the problem we are solving? They told only, is there any significant difference? So we are telling there is no significant difference. That's what the first one, there is no significant difference. Now we are telling, yes, is there some difference is there? That's what we put it, not equal. Alpha equal to 0.05. So now the two-tailed test, the level of significance is 0.05. We want the tabulated value. The initial stage itself of this video lecture, the table, the critical value of Z, we discussed it. So yes, this is the table we discussed. Now, two-tailed test. Yeah, here it is available. Then alpha equal to 0.05. So this is the value 1.96. So alpha equal to 0.05 is 1.96. The test statistic is, that is Z equal to x1 bar minus x2 bar divided by square root of sigma 1 square divided by n1 plus sigma 2 square divided by n2. What are the data? Every data is available. That is x1 bar. That is Mumbai, that MBA grades, the sample mean is 20,150, whereas Chennai, the sample mean is 20,250. Sigma 1 square, it is given, that is variance of the first variance of the population is sigma 1 square, N1, that 100 samples are taken from Mumbai, and this is 60 are selected from Chennai. So we did the calculation. The numerator part, the calculation is minus 100. So we can see it here. And the denominator is square root of 400 plus 540. So finally we obtained minus 100 divided by square root of 940. Simplifying, we obtained minus 100 divided by 30.66, the final output is minus 3.26. So we need mod Z. So the modulus of Z is 3.26. So the tabulated value is 1.96, whereas calculated value is 3.26 using this test statistic. Always, what is defined on a null hypothesis, to accept this tabulated value should be greater than calculated value. But unfortunately, our tabulated value is less than the calculated value. So what we defined on the null hypothesis, we are not in a position to accept. So it is rejected. So we can see it, the tabulated value of Z at 0.05, level of significance is 1.96. So the calculated value of Z is 3.26. So the tabulated value, which is less than calculated value. So 1.96 is less than 3.26. So the null hypothesis is rejected. So the same problem, how we can graphical representations, we can see it. So this is the bell-shaped normal curve that is at Z equal to 0. In this point, the mean is 0. The scale is x minus mu by sigma. So if that x is taking the mean, it is becoming 0. So it is, we can see it here, two-tailed test. So the two sides, shaded areas will be there. The shaded areas are rejected areas. This is the area what I am circling, that is accepted areas. Now our tabulated value, that is 1.96. So this is minus 1.96 to 1.96, completely accepted area. This is the part of the two sides, the tailed, the shaded are rejected areas. The graphical representation of the given problem is which is the accepted regions, what are the rejected regions. We can see that the arrow mark, they are denoting, they are giving a clear picture about us, that to us, which is the rejected and accepted regions. Here, so first actually, we accepted the statement what is defined, the problem. So this is the problem we are solving now. Is there any significant difference? It is the question which is asked us. So we calculated using the test statistic, we obtained 3.26. But the tabulated value should be more to accept the null hypothesis. Yes, is there any difference? So we are not in a position to accept the null hypothesis because the tabulated value, which is less than the calculated value. So there is a difference between salaries of MBA grades. We rejected what is defined on null hypothesis. H0 is rejected. We will move to the next problem. Samples of students were drawn from 2 universities and from their weights in kilograms. The weights they are giving in the scale, kilograms, mean and standard deviations are calculated and shown below. Make a large sample test to test the significance of difference between the means. Here, the University A, the data which is given, University B, that is first this data is University A, mean is 55, University B, mean is 57. Then University A, standard deviation is 10, and University B, the standard deviation is 50. So University A, how many samples we have taken? 400. From B, we have taken 100. What is the difference between the before problem and this problem? Before problem, sigma 1 square, that is variance of the population, first population, variance of the second population which is given. Whereas here, University A is that University B. From University A, we have taken 400 samples. University B, we have taken 10. So which is related to that sample only the standard deviation. Here also related to that B standard deviation is given. Here there is no picture about population standard deviation. Population standard deviation, the symbol is sigma. If it is sigma square, variance of population. But in this problem, completely regarding sample standard deviation only which is given. So to write the test statistic, the difference will be coming. Before, x1 bar minus x2 bar divided by square root of sigma 1 square by n1 plus sigma 2 square by n2. But here, there is no sigma 1 square and sigma 2 square. Here completely 55, 57. Yeah, ready they are x1 bar, x2 bar. This is n1, this is n2. What about this? We can't take a sigma that is related to population. So another thing, what is the standard deviation of sample? First one we can S1, this is S2. This point we have to be very clear reading the question, the standard deviations, whatever the data which are given in the question, whether they are related to population or they are related to sample, that clarity we have to get. So first, so the explanation of the question is over. So we will write it starting the solution. N1 equal to sample size equal to 400. So x1 bar, the first sample mean is 55. S1 equal to first standard deviation of sample 10. N2 is sample size 100. That is our university B. X2 is 57 sample mean. Then S2, the standard deviation of the sample is 15. So whatever the data which are given according to the notations with a symbol we have written. Yeah, first we are telling there is no difference. mu1 equal to mu2. Yes, no, we are not in a position to accept it. So two-tailed test we have taken H not, that is a null hypothesis defined a symbol. Alternative hypothesis is H1. Level of significance alpha equal to 0.05. The question which is not given, it does completely the problems. If it is not given, default we have taken 0.05. It is 0.01 also we can take it. Yes. Now two-tailed test. Yes, we are focusing 0.05. So 1.96 is the tabulated value. So it is written. Then the test statistic. Yes. Here, the before problem, in this particular place, sigma 1 square is there. Here, sigma 2 square. In this problem, S1 square, S2 square. The reason is standard deviation of samples are given. So we selected, we replaced, that is, instead of sigma 1 square as S1 square, sigma 2 square as S2 square. So the respective places, we substituted the values, that is x1 bar as 55, x2 bar as 57, and S1 square is 100, S2 square is 225, N1 is 400, N2 is 100. So the simplification, the numerator part is -2, the denominator part is square root of 1 by 4 plus 9 by 4. So the next ultimately we obtained -2 divided by square root of 2.5. So -2 divided by 1.58. The final output is -1.26. So Z, the test statistic using Z equal to x1 bar minus x2 bar divided by square root of S1 square divided by N1 plus S2 square divided by N2 is -1.26. But we will find mod Z, that is 1.26. So we obtained the 4 steps we completed. So the next one is the tabulated value of Z at a 0.05 level of significance is 1.96. So the calculated value of Z is 1.26. So the tabulated value, we got it. This is the tabulated value. This is the calculated value. Tabulated value is more than our calculated value. If it is more, that is the tabulated value, then what is defined as the null hypothesis is accepted. So we accepted. So our graphical representation of this problem we can see now. That is, this is a normal curve and we have taken the two-tailed, that means two vertical lines from the point minus Z alpha to Z alpha. Here the point is the tabulated values minus 1.96 to 1.96. This is the what I am shading. This region is rejected because here we can see it very clearly. The final output of this graphical presentation, which is gives us the clear picture with the arrow mark, which is the accepted and rejected regions. Here, this is 1.96 to 1.96. We obtained 1.26, so it falls in this region only because it is 1.26. So the region is accepted. That means what we defined on the null hypothesis H naught colon mu1 equal to mu2, which is accepted. So we can see the question once again. This is the question. We focused here. What is the reason? We selected the test statistics S1 square, S2 square because of the sample standard deviation is given and the tabulated value is greater than the calculated value. So it falls on the accepted region. So what in this region it falls. So now the defined null hypothesis is accepted. Next, we will move to the next problem. The means of two large samples of sizes 1000 and 2000 members are 67.5 inches and 68.0 inches respectively. Can the samples be regarded as drawn from the same population of standard deviation 2.5 inches? First, the reading, they are large samples. See here the word is there. Large samples. Why? They can give only two samples also. Specifically, they have given two large samples. Yeah, this is also that initially we discussed. That is the sample size, if it is more than 30 and is greater than or equal to 30, they are called as large samples. So the first sample is 1000, second one is 2000. Then the means of this is 67.5. So the first sample mean is 67.5 and this is 68.0. So the clear picture we are getting N1 X1 bar. Yeah, the data is very clarity. We obtained it. Then N2 also very clear 2000. Yes, X2 bar also very fine. And what about we need it? We know the test statistic now. X1 bar minus X2 bar. These two datas are available. Whereas here, S1 square or sigma 1 square, two possibilities. Here the sample population is there. The two samples are coming from the same population. So here we have to take sigma 1 square. If you are taking this is sigma 1 square, what about sigma 2 square? Because this is the test statistics, we have it. This is a very beautiful problem. That is, can the samples be regarded as drawn from the same population? The meaning is both the samples, to understand very clearly, a particular section is there, 60 students. Some 3 students we are taking, they are one sample. Same section, another 3 students we are taking, they are another sample of the same population. Here also, this is one sample and this is another sample, 2 samples. 1000 related 67.5, 2000 related 68.0. But both the samples are coming from the same population. Then sigma 1 square, which is equal to sigma 2 square, it's nothing but sigma square. So far we obtained 3 test statistics. Yes, sigma 1 square, which is equal to sigma 2 square equal to sigma square. So the N1 equal to sample size equal to 1000 and X1 bar equal to first sample mean, which is equal to 67.5. N2 equal to 2000 and X2 bar equal to 68. Sigma equal to standard deviation of population 2.5. So the null hypothesis with the symbol H naught colon mu1 equal to mu2. Samples can be drawn from the same population. And alternative hypothesis, two-tailed test, the samples cannot be drawn from the same population. So with a symbol which is given H1, So the level of significance alpha equal to 0.05. So that is the tabulated value 1.96. The test statistic now, here the before the problem, the first very problem here, sigma 1 squared, sigma 2 squared dominated. The next problem, S1 square, S2 square dominated. In this problem, sigma square is dominating. So we have to be very careful the test statistic comparison study. So this test statistic, the problems, how they are related, the data, the connectivity, we have to understand. So now the respective places, the data are valid, that is 67.5, x1 bar, x2 bar is 68, and sigma square, which is replaced by 2.5 square, n1 1000, n2 2000. So the numerator part we obtained minus 0.5. Here the 2.5, the whole square is common, we have taken out. So the left is over is 1 by 1000 plus 1 by 2000. So here the numerator minus 0.5 divided by square root of, so 2 point, the whole square is 6.25, and 1 by 1000, 0.001 plus 0.0005. So the final, the fraction we got it minus 0.5 divided by square root of 0.009375. It's nothing but minus 0.5 divided by 0.0968. The test statistic of Z we obtained minus 5.16. So mod Z is 5.16. So before going to the next slide itself, we can declare, that is, the samples can be drawn from the same population. That is the statement we defined on our null hypothesis. Here our tabulated, the value is 1.96. Here our calculated is 5. It is rejected. One thing we have to be very clear about this calculated value, that is the critical, that is the values of Z. If it is the tabulated calculated value is more than 3 comes, because the tabulated value maximum 2.58 is there. If it is more than 3, the calculated value compulsory, it is rejected. So in this problem also, the tabulated value is 1.96, which is less than 5.16. So the tabulated value of Z at 0.05 level of significance is 1.96. Calculated value of Z is 5.16. So the tabulated value, which is less than the calculated value, that is 1.96, which is less than 5.16. So hence the null hypothesis, which is rejected. So our normal curve with a symmetrical line, which is ready now, and we are going to plot the two-tailed the graph with the two vertical lines at the points minus Z alpha and Z alpha. So the final graphical representation of the given problem is with accepted and rejected regions with a marked arrow marks. Now, how this problem, why we rejected it? What is first given in the question? So this is the question. Here only the data which are given only about samples. There is no point of that population. Two population they didn't mention at all. Sigma 1 and sigma 2 put together, they told both the samples from the same population. That is what sigma square we selected. And we made it, they are coming from the same population, and we rejected the alternative hypothesis. We have taken two-tailed test that is not equal. So our tabulated value, which is less than 5.16, the 5.16 which is playing the role of calculated value, so it is rejected what we defined on the null hypothesis. So finally, we declare the result. Samples cannot be drawn from the same population. Yeah, we will move to the next problem. A researcher wants to know the intelligence of students in a school. He selected two groups of students. In the first group, there are 150 students having mean IQ of 75 with a standard deviation of 15. Yes, the first group, 150 students. Our N1 is ready. And that particular 150 students, average mean X1 bar is ready, 75. Same that sample only the standard deviation. So S1 is ready. Next, the second group, there are 250 students. Yes, our N2 is ready. Having mean X2 bar is ready. Then S2 also ready. So here completely one group with the datas 150, 75, 50 as sample size, sample mean, sample standard deviation. Second one, X2 bar, this is N2, X2 bar and S2. And what about here? Generally they told population regarding, there is no information at all. These two samples regarding the data are given. So the test statistic X1 bar minus X2 bar divided by square root of S1 square divided by N1 plus S2 square divided by N2 should dominate. Here there is no sigma 1 square and sigma 2 square. So the first one is, what we discussed, we can write it under the solution. N1 equal to sample size equal to 150, X1 bar equal to 75, S1 equal to first standard deviation of sample 15, N2 sample size is 250, X2 bar second sample mean is 70, S2 equal to second standard deviation of sample 20. So what are the data are there available? We listed out. Now the null hypothesis, that is H0 is the symbol of null hypothesis. Mu1 equal to mu2. The groups are from the same population and we are going to reject selecting two-tailed test. Why we selected the two-tailed test? There is no decrease or increase or more or less the informations which are not given to do the comparison. So we have taken the groups are from the same population. We are rejecting in such a way that they are not from the same population. So level of significance is alpha equal to 0.05. Now we are very familiar. At 0.05, the two-tailed test value is 1.96. This is obtained from the table of the chart of critical value of Z. So the test statistic, yes, S1 square and S2 square, they are dominating. So the respective places, we substituted the values, that is X1 bar as 75, X2 bar as 70. So the square root of S1, which is given 15, so 225 divided by 150, S2, it is given 20, so the 20 square 400 divided by 250. So the simplification, the numerator, we obtained 5 and square root of 1.5 plus 1.6. Here actually it should come, 5 by square root of 1.5 plus 1.6 equal to, here 5 should be there, plus 5 square root of 3.1. So we obtained final result is 2.84. So here this is plus 2.84 because here we are getting the positive output only. This is plus 5. So the calculated value we obtained 2.84. So the tabulated value of Z at 0.05 level of significance is 1.96. So the calculated value of Z is 2.84. So the tabulated value which is less than the calculated value, so it is the null hypothesis is rejected. Yes, our symmetrical, the normal curve which is ready now, and we selected the two tail, the vertical lines from minus z alpha to z alpha, that is minus 1.96 to 1.96. The final output of the graphical representation of the given problem is with the arrow mark. We can see it, how it is defined. So now mu1 equal to mu2. That is a null hypothesis we defined. That is both the groups are from the same population. We accepted it. But now our tabulated value which is less than our calculated value. So what we defined on the null hypothesis, we are not in a position to accept. It is rejected. So the final decision is declared that the groups are not from the same population. That's what here we have seen it. The question itself, it is very clearly given here. A researcher wants to know the intelligence of the students in a school. So these two, that is both the groups are from the same population. So the next problem we can focus, that is 2 tires of new cars produced in USA are tested for petrol mileage. One sample is consisting of 42 cars, average 15 kilometer mileage it gives, while the other sample consisting of 80 cars average the mileage which gives 11.5 kilometer with population variance. Yeah, first we have to, 2 samples are there. That is one sample, it has 42 cars. Our N1 is ready. That 42 cars N1 related to that particular sample, what does it mean? Yes, our X1 is also ready. Then, so N1 is ready, X1 bar is ready. Another group, that is 80, N2, 80 samples. For that, related to X2 bar also ready. So this, here the population variance is given. So sigma 1 square, sigma 2 square is given. Here we have to take the test statistic. X1 bar minus X2 bar divided by square root of sigma 1 square divided by N1 plus sigma 2 square divided by N2. Test whether there is any significant difference in the petrol consumption of 2 types of cars. Here specifically they told alpha, that is the level of significance, we have to select 0.01. So two-tailed test we can take, assuming first mu1 equal to mu2. There is no difference in petrol consumption, both are equal. We will define that on the null hypothesis. Now first we will move to the solution. First, what are the data with the simple notations we will write it. So N1, the sample size, that is the 42 cars. X1 bar, first sample mean 15, sigma 1 square, first population variance 2.0. N2, the sample size is 80, and X2 bar, second sample mean is 11.5. Sigma 2 square, second population variance is 1.5. So now the points we can see it here. The first one, null hypothesis, H0 colon, mu1 equal to mu2. There is no difference in petrol consumption. That is a statement we are defining on the null hypothesis with the notation H0 colon mu1 equal to mu2. Alternative hypothesis, H1 colon mu1 which is not equal to mu2. We are telling that yes, there is a difference in petrol consumption. Alpha equal to 0.01 specifically, which is given in the question. So here two-tailed test, yes, 0.01 which is given. Here it is there our 1%, 0.01. So this is the tabulated value. Yeah, which is which is written here 2.58. So the test statistic is here z equal to x1 bar minus x2 bar divided by square root of sigma 1 square by n1 plus sigma 2 square by n2. So the respective places, we can substitute that. So x1 bar, that is 15, x2 bar 11.5 divided by square root of 2 by 42 plus 1.5 by 80. So the numerator, which is dominating, 3.5 divided by the square root of 0.0476 plus 0.01875. So the fraction what we obtained is 3.5 divided by square root of 0.06635. So fraction 3.5 divided by 0.2576 to the lowest form. So the final result is 13.586. Here itself we can see it. The calculated value 13 point something, whereas our tabulated is only 2.58. It is rejected. So we are not in a position to accept that there is no difference in petrol consumption is wrong. There is a difference because the tabulated value is less than the calculated value. We are not in a position to accept the null hypothesis. What is the defined statement on that? So the tabulated value of z at 0.01 level of significance is 2.58. Calculated value of z is 13.587. The tabulated value, which is less than the calculated value, that is 2.58, is less than 13.587. So the null hypothesis H node is rejected. So the graphical representations, normal curve, the bell-shaped curve, and two-tailed test, that is minus z alpha, that is the left vertical line, and the right vertical line, it is initiated from z alpha. So the final output of the two-tailed, the graphical representations, we can see it here. Yes. Now in this problem, this is a question. Just now what we solved it. Here it's a thing of 2 cars, 42 cars and 80 cars, and population, the data which are given. And is there any significant difference? First we told there is no significant difference. We rejected in such a way there is a difference. This is the tabulated value. It is less than the calculated value. The null hypothesis is rejected. So alternative hypothesis is dominating in this problem. So there is a difference in petrol consumption. So the next problem is a simple sample of the height of 6,400 English men has a mean of 67.85 inches and a standard deviation of 2.56 inches. Fine. That is 6,400 English men N1. So the related to the English men, the samples, the mean is x1 bar is 67.85. This is sample standard deviation. S1 is 2.56. A particular group of N1, x1 bar, S1, the data are ready. Next, while a simple sample of heights of 1600 Austrian, so N2 is ready, 1600 has a mean of x2 bar 68.55, and here the S2, the standard deviation is 2.52. Completely the two samples, the related informations are given. Do the data indicate that the Austrians are on the average taller than Englishmen? Taller than. They are comparing. So first actually Englishman. The Englishman is coming from the population mu1. Austrian is mu2. So they are telling Austrians they are taller than the English. So if you are taking Austrian mu2, so mu2 is more. Englishman is mu1. So mu1 is less than mu2. Or mu2 is greater than mu1. Both are mathematically same. And alpha, which is given 0.01 level of significance. Here, in this particular problem, we can't take a not equal. Here they put a question taller than. So the N1, the sample size, that is Englishman, 6,400. X1 bar, first sample mean, 67.85. S1, first standard deviation, 2.56. N2, 1,600. X2 bar, 68.55. S2 is second standard deviation of sample, 2.52. So all the data which are available in the first the question we listed. The null hypothesis, Englishmen and Austrians are equal in heights, we are telling. We are telling there is no difference in heights, both are equal. That's what mu1 equal to mu2. Mu1, that is related to Englishman. Mu2, the population related to Austrian. They are telling Austrians are taller than the Englishman. That means, otherwise Englishmen are not taller than the Austrians. That's what here written. Here, if it is, we can write it mu2 greater than mu1 also. Both are mathematically equal. So the left-tailed test, because of the symbol less than. Alpha equal to 0.01, it is given in the question. Yes, here we can see it a left-tailed test that this is. And 0.01 here. So this is the value, minus 2.33. So in the chart we have seen minus 2.33, but here it is 2.33. Which direction? The point, the tabulated point, purpose, the negative. Always we will take tabulated value or calculated value modulus of that. So the test statistic is x1 bar minus x2 bar divided by square root of s1 square divided by n1 plus s2 square divided by n2. So all the values, the particular places we substituted it, that is 67.85 minus 68.55. So square root of 2.56 the whole square divided by 6,400 plus 2.52 the whole square divided by 1,600. So the numerator is minus 0.7, whereas the denominator, the simplification is square root of 6.5436 divided by 6,400 plus 6.35 divided by 1,600. So minus 0.7 divided by square root of 0.001 plus 0.004. So the final fraction we obtain, minus 0.7 divided by square root of 0.0707. So minus 9.9. That is, modulus of z is 9.9. Here itself we can easily declare what is this defined, that is Englishmen and Austrians are equal in heights. It is rejected. Why it is rejected? Because our tabulated value is 2.33. But whereas our calculated value is 9.99. Tabulated value should be more to accept the null hypothesis. But unfortunately, we obtained in this particular problem, our tabulated value 2.33 is less than our calculated value 9.9. So the null hypothesis we are not in a position to accept. In this problem, alternative hypothesis is dominating because null hypothesis is rejected. So we are writing the solutions in a presentation way, that is tabulated value of z at 0.01, level of significance is 2.33. Calculated value of z is 9.9, that is tabulated value which is less than calculated value, that is 2.33 is less than 9.9. So null hypothesis H naught is rejected. Now we can see the normal curve. So the normal curve, and it's here the graphical representations we are seeing only one vertical line in the left side because we concentrated here only the left tail. That is here, that is 2.33 is our tabulated value. Here it is there. In the chart also we notice it. It is written minus 2.33. That's what minus Z alpha. So we can see it here. Here are the graphical representations. We can see it. The left tail, that is left tail, it's nothing but one-tailed test. First, mu1, that is the Englishman, mu2, Austrian. Both are in equal heights. We defined in the null hypothesis. But the result what we obtained, the tabulated value, that is 2.33, which is less than the calculated value. So null hypothesis is rejected. Alternative hypothesis we have to take into consideration. That is, Austrians are taller than Englishmen. So next, the problem in a survey of buying habits. 400 women shoppers are chosen at random in supermarket A, located in a certain section of the city. So 400 women, that supermarket A. Their average weekly food expenditure is 250 with a standard deviation of 40. Here one group is given, that is 400 women, that is N1. Their average, that here is the average weekly X1 bar, and from the sample related standard deviation, that is S1. Next, our N2, 400 women shoppers chosen at random in supermarket B in another section of the city. The average weekly food expenditure is 220. Here also our X2 bar is ready. The same standard deviation related to sample which is coming. So it is S2. Test at 1%, that is 0.01 level of significance. What they are telling to test whether the average weekly food expenditure of the two populations of shoppers are equal. So we can tell the food expenditure are equal. That is a null hypothesis we can define in such a way that H0 colon mu1 equal to mu2. Alternative, we will tell no, they are not, food expenditure is not equal. So the solutions we can say it now. N1 equal to sample size equal to 400. Fine. X1 bar, yes. First sample mean equal to 250. S1, yes. First standard deviation of sample equal to 40. Next, N2 equal to 400. X2 bar equal to second sample mean, that is 220. S2 equal to second sample, standard deviation of sample is 55. So the null hypothesis H0 colon mu1 equal to mu2, food expenditure of shoppers are equal. Alternative hypothesis is two-tailed test, food expenditure of shoppers are not equal. So the level of significance alpha equal to 0.01, which is given in the problem itself. So here we can see it, it's a two-tailed test. We selected the two-tailed test, 0.01, this one. So the tabulated the value is 2.58. So the test statistic, we can see it, x1 bar minus x2 bar divided by square root of s1 square divided by n1 plus s2 square divided by n2. We are substituting in the particular places that x1 bar is 250, x2 bar is 220. Divided by square root of S1 is 40 square divided by 400 plus S2 is 55. That is a standard deviation of the second one. So 55 the whole square divided by 400. So the numerator we obtained 30, whereas the denominator square root of 1600 by 400 plus 3025. 3025 divided by 400. So the fraction we obtained 30 divided by square root of 11.5625. The lowest form 30 divided by 3.4, which is equal to 8.82. So mod is that also 8.82? Yes. Before moving itself the next slide, here itself we can declare our result. That is tabulated value 2.58, whereas our calculated value is 8.82. The calculated value more than 3, no need to closing our eyes, we can tell null hypothesis is rejected. And one more point also, our tabulated value is less than the calculated value. So the null hypothesis, what is defined? Food expenditure of shoppers are equal. We are not in a position to accept. It is rejected. So the tabulated value of Z at 0.01 level of significance is 2.58. The calculated value of Z is 8.82. So the tabulated value less than calculated value, that is 2.58, is less than 8.82. Hence the null hypothesis H0 is rejected. So the normal curve, and we have taken a two-tail. So both the sides, the shading from, that accepted region is from minus Z alpha to Z alpha, that is minus 2.58 to 2.58. Two-tailed test at 0.01. This is the rejected region, two tails. So we can see to more very clarity about the accepted and rejected region, this graphical representation which helps us to get the clarity. That is, here we can, the very clear picture here we can seeing that two groups. Here clearly they gave here whether the average weekly food expenditure test the level of significance, whether the average weekly food expenditure of the two populations are equal. They are equal. We have taken null hypothesis. We rejected in such a way, no, they are not equal. Null hypothesis is rejected because of the tabulated value is less than the calculated value. We have to, what is correct? Alternative hypothesis. That's what, food expenditure of shoppers are not equal. Yeah, we will move to the next question. The mean yield of wheat from a district A, capital A. So that is the name of the district we are assuming as capital A, was 210 pounds. With the standard deviation 10 pounds per acre from a sample of 100 plots. So the two lines of this question itself, which gives us the information about it. That is, here the mean district A, find x1 bar is ready, and related to that the standard deviation is there. So S1 is 10, N1 is 100. The next line, in another district, the mean yield was 200 pounds. So the next x2 bar is 200 with the standard deviation 12. S2 is 12, yeah, which is also ready. From a sample of 150, N2 is 150. So x1 bar, x2 bar, N1, N2, S1, S2. All the data's informations we obtained from the question. Assuming that the standard deviation of yield in the entire state was 11 pounds, then what is this data? Yeah, the question which is confusing us. Everything is the data which is available, then what is this 11? It is a big question. The doubt actually now it is coming, what we understood is correct or not. Yeah, everything is correct. Here, what they are saying, the question, one sample we have taken, that is, and second sample is B. Both are coming from entire state. A simple one, a particular section. That is, if you are taking the section, the total, the students of the particular section, if you are taking population, 3 students, one group, another 3 students, one group. But both The two groups are from the particular section only. Here also, district A, district B, both the districts are from the state. One particular state. That state standard deviation is given 11. So here, both the samples are coming from the same population. This type already, one problem we discussed it. Sigma 1 square equal to sigma 2 square equal to sigma square. So that's what. Here what they are asking us to check. Test whether there is any significant difference between the mean yield of crops in the two districts. So here we listed it. Sigma 1 square equal to sigma 2 square equal to sigma square. N1 equal to sample size equal to 100. X1 bar, first sample mean which is equal to 210. N2, sample size 150. X2 bar, second sample mean is 200. And sigma equal to standard deviation of population is 11. Why we neglected? Here, this 10 and this 12, we didn't take into consideration because both the sample standard deviation we didn't take into account. Both the sample standard deviation more than population standard deviation is given. So the population standard deviation is dominating and both the samples are coming from the same population. Easy way, district A, district B, both are belonging to the one particular state. So sigma is 11. So the null hypothesis, H0 colon mu1 equal to mu2. There is no difference we are telling. Then alternative hypothesis, we are telling no. There is a significant differences there. So the level of significance is 0.05. So the tabulated value is 1.96. So the test statistic is z equal to x1 bar minus x2 bar divided by square root of, actually usually it should be sigma 1 square divided by n1 plus sigma 2 square by n2. But sigma 1 square, sigma 2 square, they are replaced by sigma square because in this particular problem, district A and district B, both are coming from the entire state. So the particular places we replaced their values, that is 210 in the place of x1 bar, 200 in the place of x2 bar. Sigma is taken as 11 and n1 as 100 and n2 as 150. So the simplification part, the numerator 10, whereas the denominator, the 11 square is common, we have taken out. So the square root of 11 square of 1 by 100 plus 1 by 150. So finally, we obtained 10 divided by square root of 121 of 0.01 plus 0066 equal to the fraction. What we obtained 10 divided by square root of 2.0086. So 7.05. So the modulus of z is 7.05. So we can take a decision whether the null hypothesis we have to accept or reject. Tabulated is 1.96, calculated is 7.05. It is rejected. So there is no difference we are telling. Sorry, that is wrong according to this problem. So that wrong. How we can put it in the presentation? Tabulated value of z at 0.05, level of significance is 1.96. Calculated value of z is 7.05. So the tabulated value of z is less than calculated value, that is 1.96 is less than 7.05. Null hypothesis is rejected. So the normal curve, and we have taken a two-tailed test, that is from minus z alpha to z alpha, and the final output of the graphical representation with accepted and rejected regions with the marked arrow marks which gives a clear picture about us. That is here minus 1.96 to 1.96 is our accepted region, whereas we got the calculated is 7.05. This is the region it falls. So that is what here our problem. So this is the question. Here they told, is there any significant difference? So we selected for that purpose the two-tailed test, and we rejected in such a way not equal. So not equal two-tailed test. This is the graphical representation of two-tailed test. Because of this is the data we obtained. So the null hypothesis is rejected. Alternative hypothesis is dominating in this problem. Yes, there is a significant difference. So we will move to the next problem. That is the mean life of a sample of 10 electric bulbs was found to be 1,456 hours with a standard deviation of 423 hours. A second sample of 17 bulbs chosen from a different batch showed a mean life of 1280 hours with a standard deviation of 398 hours. So a part of the question we have read now. So from this, yes, N1 is ready 10, and this is the mean life of that 10 particular bulbs. That is X1 bar, that is 1456 is ready. This is also the data, the standard deviations related to the sample is 423. A group of the data which is now clear. So the next one is second sample, N2 is 17. So their mean, that is X2 bar, is 1280. Here, the particular sample standard deviation is S2 is 398. So we can see the next. Is there any significant difference between the mean of two batches? First, we will tell there is no significant difference on the null hypothesis. And alternative hypothesis, we will tell, yes, there is a significant difference. We can see it how we can solve this problem. So N1 equal to sample size equal to 10. X1 bar equal to first sample mean, that is 1456. S1, first sample standard deviation of sample, that is 423. N2, the sample size is 17. X2 bar, second sample mean is 1280. S2, sample standard deviation of sample equal to 398. In this particular problem, there is no sigma 1, sigma 2, because sigma 1, sigma 2, the standard deviation related to population. So the first point, null hypothesis, H0 colon mu1 equal to mu2, there is no significant difference. Alternative hypothesis, that is H1 colon, we are saying yes, there is a significant difference. So the level of significance equals 0.05. So it is 1.96. The test statistic, which is dominated by the numerator and denominator, is x1 bar minus x2 bar divided by square root of s1 square divided by n1 plus s2 square divided by n2. And the particular places we replaced the values, that is 1456 minus 1280 in the place of x1 bar and x2 bar. Whereas the denominator, that is S1, which is replaced by 423, and S2, which is replaced by 398. So we obtained 176 divided by square root of 892.9 plus 9,317.88. The fraction we obtained 176 divided by 164.96. The final output we obtained 1.067. So here the tabulated value is 1.96, whereas here the calculated value is 1.067. So the tabulated value is more than the calculated value. We can accept our null hypothesis. Yes, there is no difference. So the tabulated value of Z at 0.05, level of significance is 1.96. Calculated value of Z is 1.067. So the tabulated value is greater than the calculated value, that is 1.96 is greater than 1.067. Hence the null hypothesis H0 is accepted. The normal curve and the total area, which is totally 1, and here the particular thing, it's two-tailed test. The two vertical lines, one is from minus z alpha, another one is from the point z alpha. So the final output of the graphical representation of this problem is with the accepted and rejected regions with the marked arrow marks are given here. And what is the question actually? We can go back. In this particular question, completely the data is what I am putting the tick, all related to the samples. There is no information about population standard deviation. Simply they asked, is there any significant difference? So we have taken null hypothesis as there is no difference. That is mu1 equal to mu2. We have taken the null hypothesis. Alternative we told rejected in two-tailed, that is not equal. So we obtained, that is the tabulated value is more than the calculated value. The null hypothesis is accepted. Yes, there is no significant difference. Yes, we will come to a conclusion of this topic, test of significance for difference of means. What is population? What is the definition of the population? We discussed. And what is sample? And what is the relationship between population and sample? Critical value of Z, the tabulated value, which gives the decision to take what is defined of the null hypothesis to accept or not. What is the test statistic we used it? X1 bar minus X2 bar square root of sigma 1 square divided by N1 plus sigma 2 square divided by N2. Sigma 1 square, which is replaced by the standard deviation of samples S1 square and S2 square. If both the samples are coming from the same population, then sigma 1 square and sigma 2 square, they're replaced by sigma square different. The test statistics related to our difference of means. Two means are given. We discussed in detail. There is nearly more than 9 problems we discussed in this video lecture regarding two means. This is the first, the graphical representation of the first problem. The second one also two-tailed test. And the third problem also, it is a two-tailed test in a different, each problem in a different way we handled it. So the fourth one, this is the graphical representation. And the fifth one, the graphical representations in a different way. Here 2.58 is the tabulated value we obtained. The sixth one, here the tabulated value we obtained 2.33. Whereas problem 7, 2.58, this is the two-tailed test we obtained. And coming to the problem 8, here 1.96, whereas the calculated value is 7.05. In detail, it is discussed where the 7.05 falls. And the final, the problem 9, that is here, it is a accepted one. In detail, the graphical representation which is given. So the concept of test of significance for difference of means, it is discussed in this video lecture. Thank you very much to you all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.